Firestore and the real-time database are great for storing application data, but they're really just meant for documents that are smaller than 1 meg total. So, what if you want to store anything larger than that, like images or even videos? Well, for that, you can use cloud storage for Firebase. Hey, I'm Peter from the Firebase team, and in this video, I will walk you through how to use cloud storage in your SwiftUI app. We'll look at uploading, downloading, and securing your data, both for small files, such as an image of your dog, or large files like a song or even a video. And as always, the sample app is available on GitHub. There are 2 folders. One contains the finished app, and the other one the starter version. So if you like, you can clone the repo, open the starter version of the app in Xcode, and code along. OK, so before you can use cloud storage in your Xcode project, you need to add the Firebase SDK and then add the cloud storage library to your build configuration. Now, I've already added the Firebase SDK in the previous video. If you haven't done this yet in your own app, check out this video and follow the steps to add Firebase. All right, so if you already added Firebase like I did, then you will need to add the cloud storage library to your build configuration. If you're doing this for the first time, it might be a bit difficult to find, so let me show you. First, select the root node of your project in the Project Navigator. Then, select your target in the Targets section. Scroll down to Frameworks, Libraries, and Embedded Content. Here, you will see a list of all the other libraries that you've added to your build target. So as you can see, I previously added Firebase Auth, Firestore, and a library called Lorem Swiftum that I use to generate demo data. To add a new library, click on the plus icon. So this dialog lists all the libraries that are available to your project. Some of them are part of the operating system your target compiles against, and some come from any SDKs you might have added. So it is a long list, and if you don't want to browse through the entire list, you can just use the filter field to quickly find what you're looking for. So I will type in storage, and voila, here is the Firebase storage library. I click on Add to add it to my project, and that's it. Xcode will automatically add Firebase storage to the linker phase, and you're all set. There is one more step you need to take before you can use cloud storage in your app, and that is enabling it in the Firebase console. If you haven't enabled cloud storage for your project, you will see a screen like this. Click on the Get Started button to enable storage for your project. In this next screen here, you need to choose if you want to set up security rules for production or testing. Security rules are important for keeping your users' data safe, and you should write security rules that match the use case of your application. Later on in this video, I will show you some security rules that work for my sample app, but for now, pick Test Mode. This will allow anyone to read and write data in your project's cloud storage bucket before the date you see on screen. In the final step, you need to decide in which geographic region you want your data to be stored. This is where Firebase will create the default bucket for cloud storage. There are a bunch of regions you can choose from, and it's a good idea to pick a location that is close to where your users are. Click on Done, and Firebase will set up the storage bucket for your project. Once it has finished, you will see the cloud storage browser where you can upload files, view their metadata, such as their content type, their size, and their storage location. And if your file is an image file, you can even preview it. You can also delete files. Now, being able to perform all those operations using the Firebase console is incredibly useful, but we're here to write some code, so let's get cracking. Here in my sample app, the user can upload an image of their favorite pet, like this cute little puppy here. Once the user selects an image, the upload starts and they will see a progress bar. When the upload has finished, they will see the image of their pet in this image view. Oh, isn't that sweet? So there are two main steps to uploading an image. First, you have to tell Cloud Storage where to store the file using what's called a storage reference. Once you've got the storage reference, you can then call the putData API and upload the image data. This is an asynchronous operation, and in the past, you would have used a completion handler to implement this. But as Firebase fully supports Swift's async await, we can make our code more readable by using the async version of this call. Now, the image I showed you is not particularly large, and I'm on a fast network, but sometimes your users might want to upload larger images, or they might be on a slow network, and you will want to display some progress. The putData API supports reporting progress while uploading data, and I will show you how to implement this in your app too. But before I can upload any data, I first need to create a storage reference. A storage reference is like a URL, and it tells you where a file is stored. We saw a storage reference earlier in this video when I showed you the Firebase console. Cloud Storage stores data in buckets, and this first part of the storage reference specifies which project and which bucket the reference points to. As for the rest of the reference, you can think of this as a path to the file's location, and you as the developer get to define this. Let's take a look at how you can create a storage reference in code. So you can start by calling storage.storage.reference. The Firebase SDK will use the information in your Google Services info.plist file to determine this first part of the reference. Then, to put all uploaded files into a folder, you can call .child_favorites.child_cutepuppy.png to create the rest of the path. And while this works, it is a bit wordy, so I'm going to use the reference with path instead. But there is a problem. If all users of the app use the same path for their favorite pet, they will overwrite any images any other user uploaded before. So we need a way to form a unique file name. Now, you might remember that this app is for storing the user's favorites, such as their favorite number or color. And in this previous video, we created a struct to hold all those favorites and then stored them in Firestore. When storing a new document in Firestore, it automatically receives a unique document ID. So, why don't we use this document ID as the file name for the user's favorite pet? I will read the document ID from the favorite property on my view model, and then use string interpolation to build the path. If the user hasn't saved their favorites yet, the document ID will be nil, so I will guard this statement to make sure the following code doesn't break. Now that we've got a reference, let's also quickly create some metadata for the image. This allows us to set the content type to image/ping, which helps any code that needs to work with our image to understand this is a ping image. With all of this in place, we can now upload the image. The view model has a property named image_data that contains the raw data of the image the user selected. Over here in the view, you can see how I use loadTransferable to create a data object from the image the user selected using the photo picker. To upload this image data, I can now take the image reference I created and call putData. As you can see in the code completion, there are a bunch of methods for uploading data. These ones here expect a completion handler, but since we are using modern Swift in this app, we can use putDataAsync instead, which supports Swift's new async await. I will hold down the Option key when picking this completion to make sure Xcode writes out the full parameter list. By pressing the Tab key, I can move from argument to argument to provide the data I want to upload and the metadata. When I'm on the final argument, I press the Enter key to resolve the placeholder to a closure. Cloud Storage will call this closure to report the progress as it uploads the file. The view model has a progress property that is connected to a progress bar, so I will go ahead and assign the fraction completed value of this progress object. For smaller files, you might just want to show an indeterminate progress banner, but for larger files, it's a good idea to show a progress bar that gives the user a rough idea of how much longer they need to wait until the upload finishes. When the upload has finished, I want to hide the progress bar. In my view code, I have a condition that makes sure the progress bar is only shown if the progress property is not nil. So I will go ahead and set this property to nil when the isFinished property on the progress parameter is true. Looking at the documentation of putDataAsync shows us that this method returns an updated metadata object of the uploaded file. This sounds like something we might be interested in, so let's assign the result and print it out. Remember, putDataAsync is an asynchronous method, so by calling it using await, we tell Swift to suspend the current task while it's waiting for the call to return. So this print statement here will only be executed once putDataAsync returns and Swift resumes execution of our task. So the upload has finished, and we should probably take note of the location of the file we uploaded. We can get a long-lived download URL for the image we just uploaded by calling the download URL method on the storage reference. Let's assign the download URL to the animal image URL property of the Firestore document, and then save the updated document back to Firestore. Now, as with everything that has to do with I/O, this call can fail, so we'll have to add a little bit of error handling code here. There, that looks better. All right, let's take the app for a spin. But before we can do that, let me quickly throttle my network so you can better see the upload progress bar. To do this, I will use Apple's network link conditioner. This is a nifty little tool that lets you modify the throughput of your computer's network to imitate all sorts of conditions that your users might face in the wild. For example, I can choose between different profiles such as 3G, LTE, or Edge. I can also define custom profiles and fine-tune parameters such as the bandwidth, how many packages should be dropped, and the latency of the connection. For this demo, I have set up a profile that slows down the network just enough to see the progress bar. Okay, back in the app, let me pick an image. Once I select the image, the upload will start, and you can briefly see the progress bar. Let's take a quick look at the Firebase console. So here is the image I just uploaded with the app, and when I click on it, we can see its metadata and a thumbnail. This is because I set the content type to image/ping in my code earlier. When I click on the image, I can see a full-size version of the image. At the end of the URL, you can see a token parameter. This is so you can share the image with other people who don't need to be signed in. This is also the same URL that we stored in Firestore, so let's take a quick look at that too. So here in Firestore, I'm in the document that contains the signed-in user's favorites, and here is the same URL that I just showed you. Okay, so the image is uploaded and the reference is stored in Firestore. However, when I launch the app again, we can see the user's favorites, but where there should be an image of the user's favorite pet, there is only a placeholder image. And this is because we're not downloading the image yet. So let's fix that. There are two main ways to download an image from cloud storage: using the Cloud Storage SDK and using a download URL. Let's first look at how to download data using the Cloud Storage SDK. As you might have guessed, we first need a reference to the image we want to download. Since the method for downloading the image is in the same view model we used before, I can reuse the code for creating the storage reference. For downloading the data of the reference into memory, I can use the data method on the image reference. This method requires us to specify a maximum size in bytes. This is to make sure we're not consuming more memory than is free on the user's device. For example, we can assume that 4 megabytes should work just fine. Downloading data from cloud storage is an asynchronous call, so we need to call it using await. We can then assign the result, which is a data object, to the image data property on the view model. And of course, let's not forget to add some basic error handling. Right. In the main view, we're listening to any changes on the image data property, so when I run the app again, the image view will show the image we uploaded previously. Now, this works fine, but it's also a bit tedious. And for downloading images that you might want to display in a list, like this one for example, it seems like there should be an easier way. So let's look at using a download URL instead. Over here in the favorites list view, we will check if a list item has a non-nil image URL. We can then use an async image view to download the image and display it. Let's also resize the image frame and apply a corner radius. Now, as you can see, this doesn't look like we expected it to. The reason why is that the image itself needs to be resized. To achieve this, we can make use of the content closure of the async image view. This closure will be called for the different phases of downloading the image. Here is a typical way of handling those phases. So we can either have an image. This is the case when downloading the image has finished successfully. This is also where we can resize the image. To make sure it looks nice, it's a good idea to set the aspect ratio to the fill content mode. If anything goes wrong, the error property will be set, so we can fill the entire space with red color. And finally, we might still be downloading the image, and in this case, we will show a progress view. To balance this a bit more, I'll insert a spacer to push the image to the right edge of the list row. Nice. And this is how you can use a download URL to download images from Cloud Firestore. But what if you need to handle larger files, such as music or videos? These files could easily be several gigabytes in size and certainly no longer fit into the user's device's memory. For those use cases, cloud storage has file-based APIs that allow you to download to a local file and also upload from a local file. So, let's take a quick look at an example for uploading a video file and later downloading it again. Here I've got a method that I will use for uploading a video from the user's photo library. Instead of using the putDataAsync API, I will use putFileAsync. This API takes a URL to a file that you want to upload to the cloud storage reference. The other parameters of this API work just like the ones I showed you before. You can provide the metadata for the file you're uploading, and there also is a progress closure. Since these kinds of files are much larger, using a progress bar makes a lot more sense. Once the video is uploaded, you might want to download it again for playback, so let's take a look at that too. I first set up a storage reference to the file I want to download. Then I can use the write async to file API to download the file asynchronously and write it to a local file. And just like for the upload, I need to provide a URL to a local file. Once the file is downloaded, I can use a media player like SwiftUI's video player to play the video. Now, downloading large files like this video might not always be the best option. Sometimes you'd rather want to stream the file. The good news is that AV Player supports streaming if your video has the right encoding. To make use of this, all you have to do is pass a URL to an instance of AV Player. Here I've got a SwiftUI video player that uses AV Player to playback the video. When passing in the URL to the video I uploaded in the previous step, the player starts streaming the video. Alright, so we've seen how to upload and download data, and how to use file-based APIs to handle larger files. But I can't let you go without talking about security. In the beginning of this video, we set the security rules for cloud storage to test mode. This means anyone can upload and download files to your project's cloud storage bucket until this date rolls around. And that is probably not what you want. For one, it means your app will stop working after that date, and even before that date, your user's data is not really secure, and anyone could upload any kind of data to your project. So let's take a look at a couple of ways we can make this more secure. So the first thing you can do is make sure that only people who have logged into your app can read and write data by adding this condition to your security rules file. But there is more you can do with security rules. For instance, you could set a maximum file size based on the type of data stored in the different folders. For example, you could specify that images must not be larger than 4 megabytes and videos must not be larger than 20 megabytes, like this. Or you could set up individual users folders and write a security rule that only allows users to upload to a folder that belongs to them. As you can see, security rules are pretty powerful and they help you to keep your users' data safe and secure. And there you have it. Everything you need to get started with cloud storage in your Swift and SwiftUI apps. Now, if you want to know more, check out our documentation. So, how are you going to use cloud storage? Let us know in the comments or hit me up on social media. I'm @PeterFriese on Twitter and @PeterFriese at iOS dev.space on Mastodon. Thanks for watching. Stay safe, and I will see you in the next one.